All right, let's look at the homework 2.5, problem number 9. All right, so we have a function given. This is the average daily level P of a certain pollutant in the air in parts per million, and I'm not quite sure what that means. Can be modeled by this function, so P of n is given, right? Then what we want to do is we want to find the rate at which the level pollutant is increasing. So we're talking about rate of change, right? Rate of change is another word for derivative. So instantaneous rate of change is another word for derivative. So basically we need to take the derivative P with respect to n, then plug in n equals, let's see, communities for plug in n equals 14. All right, so let's do that. All right, so let's take the derivative. So I'm going to rewrite this guy first as 0.2. Then we have a quantity 0.7 n squared plus 7n plus 23. Raise it to the 1/2 power. All right. Then we take the derivative of p with respect to n, right? 0.2 is just a constant multiple, so I'll just put it in front, right? Derivative, so put 1/2 in front. Keep the same inside function, so 0.7 n squared plus the 7n plus 23. Then subtract 1 from the power, so it's a negative 1/2 power. Then multiply by derivative of inside, which is going to be, right, 0.7, put 2 in front, so it's going to be 1.4n. And derivative of 7n would be just 7. And derivative of 23 is 0, so you get that. Right? So do a little bit of simplification, so 2n cancel out, so you have a 0.1 there. So what you get is going to be, right, so you have a 0.1 on top, and also we have 1.4n plus 7. Then all over, then we have a square root of, right, 0.7 n squared plus 7n plus 23, right? That is the derivative. So what we need to do is we just need to compute the n prime of, right, so it's a 14,000, so n is in thousand, so it's going to be just plug in 14, right? So let's try to get the value here. Answer to 3 decimal places, so I'm going to just do this, right? All right, so let's pull out a calculator. All right, I pull out a calculator, so I'm going to define the function. So I'm going to use a y1 for this. All right, so a function is, looks like, let's see, I'm going to put the 0.1 times, actually, so yeah, so that's the derivative function, right? So it's going to be 1.4. There's no, I'm going to use x instead, and plus 7, so plus 7, then divided by square root. So I'm going to do a square root here. Square root of 0.7 x squared. Let's see, where's the square? So squared, and plus 7x plus 23. All right, so this is the derivative function. So what I'm going to do is I'm going to go to quit, then go to the regular screen, and then I'm going to go to vars, right? Then y vars, so you go here, and then function 1, right? Then you have a y1, that's the function we have. Then all we have to do is plug in 14. So I'm going to put the parenthesis 1, 4, 14, and right parenthesis, then hit enter. right? We get 0.1655, so it's going to be 0.166. So it's going to be 0.166, right? Let's plug it in. So we got 0.166, right? So let's submit for testing. All right, I came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.